The e-stop system design has potential issues that need to be addressed. The system relies on control voltage to keep the interposing relay closed and the contactors energized. If the control voltage is lost, the contactors will not drop out, potentially leaving hazardous circuits energized. There's no mechanism to unlatch the contactors if control voltage is lost. This could lead to hazardous circuits remaining live, posing a safety risk. To compensate for the unlatching issue, consider a latching relay or circuit with a manual reset feature. This would provide a way to energize the contactors even without control voltage. This design may have compliance issues with NFPA 70, also known as the National Electrical Code. This code requires emergency stop systems to energize hazardous circuits during an emergency, as stated in Article 517.30. The current design may not meet this requirement if contactors remain energized after control voltage loss. UL 943, which covers electrical requirements for emergency and standby systems, also requires emergency stop systems to energize hazardous circuits under all conditions. The current design may not meet this requirement for the same reason. I suggest these recommended actions. Firstly, discuss these concerns and compliance issues with the customer and engineer. Secondly, propose a redesigned system that includes a way to unlatch the contactors if control voltage is lost, such as a latching relay with manual reset. And thirdly, ensure that the modified design receives approval from both the customer and the engineer before implementation. The system's reliance on control voltage to maintain the energized state of contactors creates a vulnerability. If this voltage is interrupted, the intended safety function is compromised. Furthermore, the absence of a dedicated unlatching mechanism means there's no way to positively energize the circuits in a control voltage failure scenario. A latching relay, in contrast to a standard relay, maintains its state even when power is removed. Incorporating a latching relay into the e-stop circuit would ensure that once the e-stop button is pressed and the relay is energized, it remains in that state, disconnecting power to the contactors. A manual reset feature would then be required to re-energize the system after the emergency has been addressed. Article 517.30 of NFPA 70 focuses on essential electrical systems for healthcare facilities, but the principle of ensuring reliable emergency shutdown applies broadly. In the context of the question, the e-stop system must reliably energize circuits to protect personnel and equipment. The current design's failure to guarantee this under all conditions raises concerns about compliance with the intent of this code. UL 943 establishes requirements for ground fault sensing and protection equipment, but it also emphasizes the overall reliability of emergency systems. An e-stop system that cannot reliably energize circuits during a loss of control power would not meet the spirit of this standard, as it compromises the system's ability to provide emergency protection. It is very important to ensure that any proposed redesign adheres to applicable codes and standards. The redesign should be thoroughly documented and reviewed by qualified personnel to ensure that it meets all safety requirements. Furthermore, it is imperative to clearly communicate the limitations of the original design and the rationale for the proposed changes to both the customer and the engineer. Transparency and collaboration are essential to ensure that the final system meets the needs of the facility and complies with all applicable regulations. Remember to obtain written approval from both the customer and the engineer before implementing any changes to the e-stop system. This will help to avoid misunderstandings and ensure that everyone is on the same page. This documentation can also serve as a valuable record of the decision-making process. In addition, consider conducting a hazard analysis of the e-stop system to identify potential failure modes and their consequences. This analysis can help you to identify potential weaknesses in the design and to develop mitigation strategies. This can be a valuable tool for improving the overall safety and reliability of the system. Regular testing and maintenance of the e-stop system are essential to ensure that it functions properly. The system should be tested periodically to verify that it energizes the circuits as intended. Maintenance should be performed to prevent failures and to ensure that the system remains in good working order. This proactive approach will help to maintain the safety of the facility and to minimize the risk of accidents. When selecting components for the redesigned e-stop system, it is important to choose products that are specifically designed for safety applications. These components are typically more robust and reliable than standard industrial components. They are also often subjected to more stringent testing and certification requirements. Using safety-rated components can help to improve the overall reliability and safety of the e-stop system. Consider adding redundancy to the e-stop system to improve its reliability. Redundancy involves using multiple components or circuits to perform the same function. If one component fails, the other component can take over, ensuring that the e-stop system continues to function properly. This can be particularly important for critical safety functions. Document all aspects of the e-stop system design, installation, testing, and maintenance. This documentation should include detailed drawings, specifications, test results, and maintenance records. This documentation will be invaluable for troubleshooting problems and for ensuring that the system is properly maintained. In addition to the technical considerations discussed above, it is also important to consider the human factors aspects of the e-stop system. The e-stop buttons should be easily accessible and clearly labeled. The system should be designed so that it is easy for personnel to understand how it works and how to use it. Training should be provided to all personnel who may need to use the e-stop system. By addressing these human factors aspects, you can help to ensure that the e-stop system is used effectively in an emergency. Consider the specific hazards that the e-stop system is intended to mitigate. This will help you to determine the appropriate level of safety and reliability that is required. For example, if the e-stop system is intended to protect personnel from potentially lethal hazards, it should be designed to be highly reliable. If the e-stop system is intended to protect equipment from damage, a lower level of reliability may be acceptable. Consider the environmental conditions in which the e-stop system will be operating. This will help you to select components that are appropriate for the environment. For example, if the e-stop system will be exposed to moisture or dust, it should be designed to be resistant to these elements. Ensure that the e-stop system is properly grounded. Grounding is essential for protecting personnel from electrical shock hazards. The e-stop system should be grounded in accordance with all applicable codes and standards. Consider the potential for unauthorized access to the e-stop system. The e-stop system should be designed to prevent unauthorized access or tampering. This can be achieved by using locked enclosures or by implementing other security measures. The e-stop system should be designed to be fail-safe. This means that if the system fails, it should fail in a way that does not create a hazard. For example, if a component fails, the e-stop system should de-energize the circuits as intended. Conduct a thorough risk assessment of the e-stop system. This risk assessment should identify potential hazards, assess the likelihood and severity of those hazards, and develop mitigation strategies. The risk assessment should be documented and reviewed periodically. Ensure that the e-stop system is integrated with other safety systems in the facility. The e-stop system should be designed to work in conjunction with other safety systems such as fire alarms, sprinkler systems, and ventilation systems. This integration can help to improve the overall safety of the facility. Provide ongoing training to personnel on the proper use of the e-stop system. This training should be repeated periodically to ensure that personnel remain familiar with the system and its operation. The training should cover topics such as how to activate the e-stop system, what to do after the e-stop system has been activated, and how to reset the e-stop system. Establish a clear procedure for resetting the e-stop system after it has been activated. This procedure should include steps to verify that the hazard has been eliminated and that it is safe to re-energize the circuits. The procedure should be documented and communicated to all personnel who may need to reset the e-stop system. Conduct regular audits of the e-stop system to ensure that it is being properly maintained and operated. These audits should be conducted by qualified personnel who are familiar with the e-stop system and its requirements. The audit should identify any deficiencies in the system and recommend corrective actions. The design should incorporate a redundant control power source. If the primary control power source fails, the secondary source should automatically switch over to ensure that the e-stop system remains operational. This will significantly increase the reliability of the system. The latching relay should have a manual release mechanism that can be used to de-energize the circuits in the event of a power failure or other emergency. This will provide a backup method of de-energizing the circuits if the primary e-stop system fails. The manual release mechanism should be clearly labeled and easily accessible. The e-stop system should be designed to prevent accidental or inadvertent activation. This can be achieved by using recessed buttons or by implementing other safeguards. Accidental activation of the e-stop system can disrupt operations and potentially create hazards. The e-stop system should be designed to minimize the risk of nuisance tripping. Nuisance tripping occurs when the e-stop system is activated unnecessarily, disrupting operations. This can be caused by electrical noise, faulty sensors, or other factors. The e-stop system should be designed to be resistant to these factors. The e-stop system should be designed to be easily expandable. As the facility evolves and new equipment is added, the e-stop system may need to be expanded to cover the new equipment. The e-stop system should be designed to accommodate these future expansions. The e-stop system should be designed to be compatible with other control systems in the facility. This will allow the e-stop system to be integrated with other control systems such as programmable logic controllers, human-machine interfaces, and supervisory control and data acquisition systems. This integration can improve the overall efficiency and safety of the facility. Consider using a distributed e-stop system. A distributed e-stop system uses multiple e-stop buttons and control units that are located throughout the facility. This can improve the responsiveness of the e-stop system and reduce the risk of a single point of failure. The control unit should be interconnected using a reliable communication network. The e-stop system should be designed to be self-monitoring. The self-monitoring system should continuously monitor the e-stop system for faults and failures. If a fault or failure is detected, the self-monitoring system should generate an alarm and take appropriate action, such as de-energizing the circuits. The self-monitoring system should be designed to be highly reliable. The e-stop system should be designed to be tamper-proof. The system should be designed to prevent unauthorized modification or tampering. This can be achieved by using locked enclosures, tamper-evident seals, or other security measures. Tampering with the e-stop system can compromise its safety and reliability. The e-stop system should be designed to be easy to maintain. The system should be designed to be easy to inspect, test, and repair. This will help to ensure that the system is properly maintained and that it remains in good working order. The e-stop system should be designed to be cost-effective. The system should be designed to provide the required level of safety and reliability at a reasonable cost. The cost of the e-stop system should be considered in relation to the potential hazards that it is intended to mitigate. Select e-stop buttons that are easily identifiable and distinguishable from other control devices. Use a consistent color scheme for e-stop buttons throughout the facility. This will help to prevent confusion and ensure that personnel can quickly locate and activate the e-stop system in an emergency. The e-stop button should be clearly labeled with the words emergency stop or a similar phrase. The labeling should be durable and easy to read. The e-stop button should be located in easily accessible locations. The buttons should be placed where they can be quickly reached by personnel in the event of an emergency. The e-stop button should be protected from accidental damage. The buttons should be protected from physical damage, such as impacts or abrasions. They should also be protected from environmental factors, such as moisture or dust. The e-stop button should be tested regularly to ensure that they are functioning properly. The buttons should be tested to verify that they activate the e-stop system as intended. The testing should be documented and the results should be reviewed by qualified personnel. The e-stop button should be maintained in good working order. The button should be cleaned regularly and any damaged or worn component should be replaced. The maintenance should be documented and the record should be kept up to date. The e-stop button should be inspected regularly for signs of damage or wear. The inspection should be conducted by qualified personnel who are familiar with the e-stop system and its requirements. The inspection should be documented and the results should be reviewed. Develop a comprehensive training program for personnel on the proper use of the e-stop system. The training program should cover topics such as the location of the e-stop buttons, how to activate the e-stop system, what to do after the e-stop system has been activated, and how to reset the e-stop system. The training program should be repeated periodically to ensure that personnel remain familiar with the system and its operation. Conduct regular drills to simulate emergency situations. These drills will help to ensure that personnel are familiar with the e-stop system and that they know how to use it effectively in an emergency. The drills should be conducted in a realistic setting and they should involve all personnel who may need to use the e-stop system. Establish a clear communication protocol for use during emergencies. This protocol should outline how personnel should communicate with each other and with emergency responders. The protocol should be documented and communicated to all personnel. The communication protocol should be tested regularly to ensure that it is effective. Maintain a list of emergency contact numbers. This list should include the numbers for the fire department, the police department, the ambulance service, and other emergency responders. The list should be posted in a conspicuous location and it should be readily accessible to all personnel. Review and update the e-stop system periodically. The e-stop system should be reviewed and updated periodically to ensure that it remains effective and that it meets the changing needs of the facility. The review should be conducted by qualified personnel who are familiar with the e-stop system and its requirements. The review should consider factors such as changes in the facility's operations, new equipment that has been installed, and any new safety regulations that have been implemented. The e-stop system should be designed to be compatible with the facility's existing electrical system. The e-stop system should be designed to be easily integrated with the facility's existing electrical system. This will minimize the disruption to the facility's operations and it will reduce the cost of installation. The e-stop system should be designed to be energy efficient. The e-stop system should be designed to minimize its energy consumption. This will help to reduce the facility's operating costs and it will help to protect the environment. The e-stop system should be designed to be environmentally friendly. The e-stop system should be designed to minimize its impact on the environment. This can be achieved by using environmentally friendly materials and by implementing environmentally sound practices.